Hello, good morning. So in the previous class we just started the module 2, that is source coding. So and also I told you what do you mean by source coding and what is a code alphabet and how the source symbols are represented in the form of code words, that is by using your code alphabet. And also we discussed about the important properties of code. So where we have block code and we have instantaneous code, then we have singular code, non-singular code, then we have uniquely decodable, non-uniquely decodable code. So we have 5 different types of codes, so where those all comes under properties of code. So then also we saw that for a code to be instantaneous, so then it should have the minimum average length. So where the minimum average length is denoted by summation of I is equal to 1 to q pi into li. So that was the equation relating the instantaneous code. So now let us look into the next topic, which is called as prefix of a code. So let us consider with respect to the prefix of a code. So let x1, x2 up to xn. So let this be a code word. So be a code word and let x1, x2, x3 up to xj. So this be also a code word of the code, be some code word of code alphabet. So for all okay. So for all xj less than or equal to xn. So this is related to the prefix of a code. So now with respect to this prefix of the code, so we have one is x1, x2 up to xn. So let this be a code word and this x1, x2, x3 up to xj. So this let be some code word what we are going to represent with the help of using your code alphabet, where that xj less than or equal to xn. So now we have an example to show what 2 is your prefix of a code means. So that means we have represented a symbol with respect to that. Correspondingly we have some code words which we have represented here, where we have considered 4 source symbols from S1, S2, S3 and S4. So corresponding to that source symbols we have the code words what we have considered here. And also they have given a code word. So this is the example what we have considered. So to indicate the prefix of a code. So now, so this code word if we consider, so how we are going to encode this is by using this particular table is, so the first bit here is 0. So 0 means, so what is the source symbol I can represent? So 0 is represented with respect to S1. Then the next bit is 0, 1 and also we have 0, 1 can be represented as S2. That means these 2 can be represented as S2. But we have one more one where I can represent this as 0, 1, 1. If I consider 0, 1, 1. So 0, 1, 1 means this I can consider or I can represent it as S3. So then we have that is S4, sorry it is S1 and once again this is also S1. That means here the condition for prefix of a code is that, so for the existence, for that is to say that an efficient condition for existence of an instantaneous code is that, so no code word should be prefix of any other code word. That means to say that, so here S1 as well as S, that means I can represent 0 as S1 only, but in order to represent the second, that is 0, 1, 1, so I should look into the next bit here. That means I can represent either it as S2 or I can represent it as S3. So that means I can say that, so here S1 is the prefix of S2. So S1 is the prefix of S2 because S2 is also starting from 0. So the first bit with respect to S2 is 0. So that means S1 can also be represented as the prefix of S2, and S2 can be represented, S2 can be represented as the prefix of S3. So because here S3 is also starting from 0, 1, where S2 is also 0, 1. That means S2 is the prefix of S3 and S3 is the prefix of S1. Since S3 is starting from 0, 1, 1. So that means 0, 1, 1 means I can represent it as, that is the first bit starting with respect to S3 is 0. So that's why S3 is also the prefix of S1. Existence of uniquely decodable code as well as the code to be instantaneous, it should not be the prefix of any other code word. Okay. So that means here what the code word, so this is the code word what we have considered. So here this is called as non-instantaneous because I cannot generate the symbols, that means I cannot represent the code word by the symbols instantaneously. That means S2 is dependent on S1 and similarly S1 is dependent on S2. So like this they are not independent, they are dependent on one another. So for the prefix of a code to be instantaneous, it should not be the prefix of any other code word. Okay. So this is regarding what do you mean by prefix of a code. So now we have the next topic which is called as the KRAFT inequality. So this for an efficient and sufficient condition, that is an efficient condition for a code to be instantaneous, for a code to be instantaneous with minimum average length, with minimum average length, where this average length is denoted by L1, L2 up to Li. So this is given by summation of I is equal to 1 to q r to the power of minus Li. So this is the condition for the KRAFT inequality. So the where the unit is binary unit. So that is bits. So if we have, depending upon the number of symbols we have, the unit is going to change. So where q represents the number of source symbols, that is total number of source symbols. So source symbols in the sense, so here if we consider this table, so we have S1 to S4, so this represents your q, that is the number of source symbols. So then we have r, small r, this represents the number of code words with respect to your code alphabet. So that means to say that if suppose if the code alphabet X, if it is binary, so then so you can represent them as 0, 1. That means you have only two possible conditions, that is 0 and 1. So if suppose if X value is 0, 1, 2, that means 3 code alphabets are used, so then the unit gets changed to trinits. Okay. So that means depending upon the code alphabet which we are used in the formation of the code word, this R value is going to change. Then we have Li. So Li represents the length of the code word. So this is the length of the code word. Length of the code word in the ith code word. Okay. So Li, that is L1, L2, up to Li. So this represents the length of the code word in the ith code word. That means, so for example, if we consider here with respect to symbol S1, so that is with respect to code A, we have the S1 source symbol is represented as 00 is the code word. So corresponding to this particular code word, so 00 means how many number of bits we have? So we have only, that is the length is 2, that is 00 means, so this is considered as 1 and 2. So similarly here if we consider, so we have the length of the code word is 3 bits. So that means, so Li represents the total number of bits which is used with respect to your corresponding code word. Okay. So now how we are going to find this particular KRAFT inequality? So where summation of I is equal to 1 to q, r to the power of minus Li should be less than or equal to 1. So this is the condition with respect to this KRAFT inequality. So where we let us see, so how this condition is going to prove, or for a code to be instantaneous, so this condition should be satisfied. So now here we have considered a simple block. So where in this particular block, so we have 4 source symbols. Corresponding to the 4 source symbols what we have considered, here they are code A, B, C, D and E other different codes which are formed corresponding to the source symbols. So now let us consider first the code A, then code B, code C and code D, and let us check whether the code is instantaneous or not, or whether it is going to satisfy this condition or not. Okay. So where the formula for KRAFT inequality is summation of I is equal to 1 to q, r to the power of minus Li less than or equal to 1. So now if we consider this one, so what is the source symbols we have? What is q? Q is equal to 4. And what is r? So since we have used only 0 and 1, so the r is equal to 2. And what is Li? So Li means, so where I is equal to 1 to q means we have 4 source symbols. So L1 is also, so L1 is length of this one, so it is 1. So L2 is equal to 0, 1. So that is also, sorry, it is 2. And L3 is also 2 and L4 is also equal to 2. That means, so each of the corresponding source symbols length is 2 for L1 to L4. So now if you substitute here, it is I is equal to 1 to 4, r to the power of, r means it is 2 to the power of minus L1. So L1 is what? So L1 is minus 2. So since the summation varies from I is equal to 1 to 4, so I can represent this as plus the L2, that is 2 power minus 2 once again. So this is also 2 power minus 2. So if we find out this value, so whatever the value you are going to get here, so if it is less than or equal to 1, so then I can say that it is instantaneous. Okay. So like this, so you are going to find for rest of the code words what is being written on the board, and you are going to check whether it is going to satisfy the condition of KRAFT inequality. So for the second, that is, this is for code A, and next we have for code B. So for code B also, so we have 4 source symbols, that is summation of I is equal to 1 to 4. Then we have the first source symbol length is 1, so it is 2 power minus 1 plus 2 power minus 3, since we have 3 source symbol, plus 2 power minus 3 plus 2 power minus 3. So, check for the condition whether it is less than or equal to 1. So, like this you are going to find for code C, code D as well as code E. So, let us look into the examples with respect to this KRAFT inequality. So, where the problem is like this, consider the following code list, identify the instantaneous code and also analyze the KRAFT inequality. That means first you need to check whether the code is instantaneous or not. So, after finding whether the code is instantaneous or not, you are going to check for the KRAFT inequality condition. So, here the example, that is the code word what they have given is this one. So, first we will check for the code K. So, for code K, so if we consider, so if we write the prefix of this particular code, so where we have 0, so 0 means it is, so 0 andre this is S1, so then we have 1 1 0, so 1 1 0 means we have S3. So, this one, so this can be written as S3. So, then we have 4 ones. So, 4 ones can be written as S5. So, then we have 3 1 with 0. So, that can be written as S4. Then we have 1 0, that means S2. So, as you can see here, so with respect to this code K, I can call this as instantaneous code because so no other code word is the prefix of any other code word here. So that's why here this is called as an instantaneous. So this is an instantaneous code. So this is for code K. So now we need to find for code L. So, for code L if we consider, so what is the first one? So, we have 0, 0, 1. So, 0, 1 means it is, so I can write it as S2. So, then we have 1, 0, 1, 1. So, where we have 1, 0, 1, so it is not present with respect to this particular code. So, hence I can say that, so this cannot be it is not an instantaneous code. Instantaneous code. So that means I am not able to represent the prefixes with respect to this code word what they have given. So and also if suppose if they form the prefixes of some other code word, then also I can say that the code is not an instantaneous code. So now we need to check for the KRAFT inequality condition. So what is the total number of source symbols we have? We have Q is equal to 5 since we have S1 to S5. So then, so if we consider code K, then what about R? So R is either 0 or 1, so R is equal to 2. So then we have the length of the bits, so where L1 is 1, then we L2 is equal to 2, L3 is equal to 3, L4 is equal to 4 and L5 is also equal to 4 bits. So now substitute in the KRAFT inequality, that is summation of I is equal to 1 to 5. So this is equal to summation of I is equal to 1 to 5, then L1 is 2 power minus 1 plus 2 power minus 2 plus 2 power minus 3 plus 2 power minus 4 plus 2 power minus 4 less than or equal to 1. So check whether you are going to get for less than or equal to 1. So if it is less than or equal to 1, so then this is for code K. Similarly, we need to find for L. So L is equal to, once again it is summation of I is equal to 1 to 5. Then we have 2 to the power of minus 1. So since the length is 1 plus 2 power minus 2 plus 2 power minus 3 plus 2 power minus 4 plus 2 power minus 4. So now if you find this, so you will be able to check whether it is less than or equal to 1. So if it is less than or equal to 1, you check for that, and if it is less than or equal to 1, then it satisfies the condition of KRAFT inequality. So here it is 0, if it is triple 1, so this will be 2 to the power of minus 5. So check for this condition whether it satisfies the KRAFT inequality. So this is how you are going to check for. The first thing is that you need to check whether the code is instantaneous or not. So they will be given you some code word. So for the corresponding code word, you need to check whether the code is instantaneous or not. So once you find the code is instantaneous, so then you need to check for the condition of KRAFT inequality. So this is about the example what we have considered. So coming to the next example here, so which of the following sets of word length are acceptable for instantaneous code. So here they have given already what should be the code alphabet. So that is R. So where we have 3 that is code alphabet, the code alphabet is represented by 3 bits here, that is 0, 1 and 2. And also corresponding to that code we have the word lengths which is given. So the word lengths are given as 1, 2, 3 and 4. So this code here represents that it has 2 source symbols. So if we consider the first one, that is summation of I is equal to 1 to 2. What is R here? R is 3 to the power of word length is minus 1. If we calculate this, you will be getting the value of the first one. So similarly, that means it should be less than or equal to 1, check for that condition. So similarly, this is for summation of I is equal to 1 to 1 because Q is 1 here. So I is equal to 1 to 1, what is the length? It is 3 to the power of minus 2. So check for the KRAFT inequality condition. Next we have summation of I is equal to 1 to 2, 3 to the power of minus 3 less than or equal to 1 agidya check ಮಾಡಬೇಕು. So next summation of I is equal to 1 to 4. So where we have 4 source symbols. So corresponding to that, what is R here? It is 3 to the power of length is 4. So for all these conditions, so here we have 2 source symbols. That means to say that, so whatever the value you are going to get here, that is 2 into 3 to the power of minus 1 should be less than or equal to 1. Check for this condition. So similarly here, so since we have only one source symbols, so it is 3 power minus 2 only. So if we consider the third condition, we have 2 source symbols with 3 power minus 3. That means it is 2 into 3 to the power of minus 3 less than or equal to 1. You need to check for this condition. So here we have 4 source symbols. So 4 source symbols with 4 into 3 to the power of minus 4 less than or equal to 1. So check for the value. So then last one, so we have summation of I is equal to 1 to 1, 3 to the power of minus 5. So you need to find whether it is less than or equal to 1 for 3 to the power of minus 5. So this is for your code A. So similarly, you also need to find for code B. So if we consider for code B, it is summation of I is equal to 1 to 2. Then we have 3 power minus 1. So 3 power minus, so this is for your code B. So it is summation of I is equal to 1 to 2, 3 to the power of minus 1, where it can be written as 2 into 3 power minus 1 less than or equal to 1. So if we consider the second one, so it is 3 to the power of minus 1, that is 2 into, since we have 2 source symbols, so it is 2 into 3 to the power of, what is the word length? It is 2. So it should be less than or equal to 1. So similarly, so for this one, so it is 2 into 2 source symbols multiply by 3 to the power of minus 3 less than or equal to 1. For this also you need to find what is the condition. Similarly, we have 3 source symbols, so it is 3 into 3 to the power of minus 4 less than or equal to 1. Check for the condition. So similarly for the last one. So this is how we are going to check for whether the code is instantaneous or not. So we are comparing this problem with this one. So here they have given, initially we need to find what is the word length. So here they have not given you any source length as well as the code word. Instead of that, they have already given you what should be the code alphabet and what should be its word length, and corresponding to that the symbols they have given with respect to code A and code B. So only thing is that you need to check for the KRAFT inequality condition whether it is less than or equal to 1. So the next problem what we have with respect to construction of instantaneous code. So this is another topic, so where we need to find what is the instantaneous code is. So where the problem statement is given like this. So find the smallest number such that W is equal to 0, 3, 0, 5. So where what is this W? So W is the set of number of words with the word length, that is 1, 2, 3 and 4. That means here the words we have the words in the sense we have the symbols which is given. So where we have 0 symbol with the length 1 and 3 with respect to 2, 0 with respect to 3 and 5 with respect to 4. So they have not given here what should be your R. So R means what should be your code alphabet. So now first we need to find out what is your R by trial and error method. So that means, so for this one, that is for symbol 0. So that means for 0 symbols means the word length is 1, so we cannot consider this one. So if we consider this one, so we have summation of I is equal to 1 to 3 R to the power of minus Li means it is R to the power of minus 2. So since we have 3 source symbols here, so it is 3 into R to the power of minus 2 less than or equal to 1. So now substitute the value of R. For example, if we consider R to be equal to 1. So if we consider R is equal to 1, so it is 1 to the power of minus 2. So 1 to the power of minus 2 means we are not going to get the condition for this one. So similarly, so that is for R is equal to 1. So for R is equal to 2, it is 3 into 2 to the power of minus 2 less than or equal to 1. So 3 into this is 2 power minus 2 means it is minus 4 less than or equal to 1. So similarly for R is equal to 3, so it is 3 into R to the power of 2 to the power of minus 3 less than or equal to 1. So that means, so like this you are going to check for the condition for R value. So whether you are going to get for R value, that means when it is going to satisfy this condition for less than or equal to 1, so you go on checking for that one. So then you are going to find what is your R value. So once you find the R value, so you will be fixing up what is your code alphabet, that means how many number of code alphabet should be present. So now once you find this R value, next we also need to find the instantaneous code. So only possible condition is with respect to the word length, that is 3 as well as for 5. That means to say that we need to find the 3 source symbols with word length of 2 and 5 source symbols with the word length of 4 using this condition. So now here in my example, so we will consider that for R is equal to 3, so we are going to satisfy the condition, that is R is, it is less than or equal to 1, or it is satisfying the instantaneous code condition. So now with R is equal to 3, so that means R is equal, suppose if R is equal to 3. So then what are the conditions I can have for code alphabet? It is 0, 1 and 2. So now I need to find 3 source symbols, that is S1, S2 as well as S3 with the word length of 2. So that means by using this code alphabet X, I need to find what are the source symbols or the instantaneous code. So now if I consider S1, so I can represent it as 0, 1. Then I can represent it as 1, 2, or I can represent it as 2, 0. That means you should keep in mind that no other code should be the prefix of any other code for the code to be an instantaneous. So now, so this is not the prefix of this one, or this is not the prefix of this one. So I can represent this as S1 as 0, 1, or I can represent it as 1, 0. So you can represent either 0, 1 or 1, 0. So this is 2, 1. So this can be represented as 0, 2. So this is also another form of representing the same set of symbols. So similarly we have 5 source symbols, that is from S4, S5, S6, S7 and S8. They should be represented with a word length of 4. So 4 means it is, I can represent it as 0, 0, 1, 0. So 0 means once again it will be the prefix of S4. So that's why I can represent it as 0, 0, 1, 2. Then I can represent it as 1, 2, 0, 1. Then it is 2, 1, 0, 2. Then 2, 0, 1, 1, 1, 1, 0, 2. So this is how I can represent, I am writing or I am constructing an instantaneous code. So using the condition which is given in the problem. Okay, the next topic is related to the Shannon's encoding algorithm. So where this Shannon's encoding algorithm is the one, so where you are going to convert the symbols with respect to their corresponding code word. So what you need to find here with respect to this Shannon's encoding is, so you need to find the different code words. So to find the different code words, so here, so let us consider the source symbols, that is S is equal to S1, S2 up to SQ, and corresponding to this let us consider the probability emitted as P1, P2, so up to PQ. So now we have some steps to be followed for this encoding algorithm. So the first step is, so you need to arrange all the probabilities which are given in the problem. So arrange all the probabilities in the, in the decreasing order, or I can say that in non-increasing order or decreasing order, such that it is P1 should be greater than or equal to P2, so it should be greater than or equal to PQ. So like this you need to arrange all the probabilities in the decreasing order. So once you arrange them in the decreasing order, the next step is that you need to compute the sequences. So what you need to do here is that compute the sequences in the sense, so initially we are considering an value called alpha here. So where that alpha 1 by default always it will be equal to 0. That means the length of this will be equal to 1. So now we doesn't know what is this alpha 2 and alpha 3 up to alpha q. That means how many number of source symbols we have. So those many number of sequences you need to compute. So to calculate alpha 2, so we have the first probability plus alpha 1 is 0. So if you find this, you will be getting alpha 2. So similarly, if we have alpha 3, so to calculate alpha 3, so we need to consider the probability P2 plus the previous computed sequence. If you add that one, you will be getting alpha 3. So like this, you need to compute up to Q Q sequences, where in general alpha Q can be written as alpha Q plus PQ. So this is the last sequence, or with respect to the Qth symbol, what you need to find the sequence. So once you find this sequences, the next step is you need to find what is the length of this corresponding computed sequence. So in order to find the length, so we are going to use an equation here. So that is 2 to the power of Li should be less than or equal to 1 by Pi. So this is the equation. So where this I is equal to 1 to 2 up to PQ up to Q number of source symbols, you are going to find the probability as well as the length. So this is how you are going to find the length of the corresponding computed sequence. So once you compute the length, so next what we need to do is that we need to expand the decimal number alpha I up to Li places. That means if suppose if the computed sequence is in the form of decimal value. So for example, if you have got alpha value, alpha 1 is equal to 1 by 2. So like this, if we get any value for this one, so sorry, it is 0.5. So if this is the condition, or if you are going to get 1 by 4 or 1 by 8, so first this has to be converted to decimal value. So if suppose if I consider 0.625, so then this decimal value has to be converted to integer. So that means how we are going to convert this into integer is you are going to perform the conversion process from decimal to binary, that is multiplying by 2. So like this you are going to find what is the alpha I value. So till where you are going to compute, so you are going to compute depending upon the length of the, so length what you have calculated from here. So up to Li places you are going to compute the decimal number. So once you compute the decimal number, so then you are going to remove the decimal point, sorry, or the binary point what you have. So that means if suppose if you are going to get for this, it is 0.110. So then you are going to remove this decimal point and you are going to consider it as 0110. So the length of this one will be 4 bits. So then, so remove the binary point and calculate the length of the bit. So calculate the length. So once you calculate the length, so then you are going to calculate the minimum average length L, that is L is equal to summation of I is equal to 1 to Q Pi into Li. So this is finally what you need to calculate for your Shannon's encoding algorithm. So in the next class we will discuss about with an example how we are going to find the encoding of this Shannon's algorithm.